Welcome back to Science Explorers. In today's video, we'll dive into the fascinating world of electrical circuits. Using interactive simulations, we'll uncover the key differences between series and parallel circuits and see how they impact the behavior of electrical components. Here are the objectives: to understand the basic concepts of series and parallel circuits, to analyze the variations in the bulb intensity, also to relate how current and voltage behave differently in series and parallel circuits. The outcomes: students will be able to explain how voltage is distributed across components. In series and parallel circuits, students will observe, describe how the brightness of the bulb is varied based on type of circuit. Students will be able to apply their knowledge of current and voltage to solve basic circuit-related problems, predict outcomes in real-life scenarios. So where are we doing the simulation? We have a circuit construction kit, a virtual lab in PHET website. I'm going to share the link in the description below. You can always check that. So what are we doing now? We are going to construct a series circuit and a parallel circuit, and we're going to compare. How do we start? We always start with a voltage source. Here is a battery. There you go. Here is a battery. Now, what do I want to do? I just want to connect a few bulbs to it. All right, let me take a bulb. All right, I have one light bulb. At first, do you remember the basics of series and parallel circuit we discussed previous lesson? Just connect. What is a series circuit? If you connect one after other. So let's connect these bulbs in series from the battery. How do you do that? There you go. From positive terminal of battery, take a wire, take one more wire, as many you can, to just make it look good, because it doesn't matter until and unless you are connecting another component. So what I do is I just use 3 wires here. There you go. 2 light bulbs connected in series next to each other. Circuit, right? So these 2 are connected. Then I'll take another one. There you go. Can I connect like this? No, I need a switch. I want to control it. Of course, I need a switch. Where do I want to use a switch? You can use it anyway. So let me take a switch somewhere to this side or this side. Okay, I'll choose this. Cut. All right. Let me have a switch there. Something like that. Okay, that should be fine. Okay, finally. So there, I have a switch. And I connected there. One more wire, just to make sure. That's perfect now. What do we do? We have a battery, a positive battery. We connect it to one bulb. The other terminal of the bulb goes to the next bulb. All right. So this is a series connection. Now let's see what a parallel connection looks like. What is a parallel connection? If more components, 2 or more components are connected exactly between the same 2 nodes, they're called connected in parallel. So let me take a switch now. Okay, so I'll take this one as one node and this as the other node. Let me take one more. Okay. All right, that should be okay. Now, what I do is connect the light bulb in parallel. What is in parallel? They must be connected between the same 2 nodes. So this is connected there, there. Okay, let me connect it like that. The other terminal in this goes to the next bulb. The other terminal in this does not go to the next bulb. Rather, we try to connect it to the other end of the battery. So that. One more. Okay. Why am I doing this? Parallel connection is connecting between the same 2 nodes. So I have that here, I have that here. There you go. Almost there. And that. So this is a series connection, and this is a parallel. Right? So if you connect one after other, series connection, connect both in parallel. What is that? Between the same two nodes there and there. This is a series connection. In both, I did not change the battery. The battery voltage is 9 volts. You can look at that. It's 9 volts here. This is also 9 volts here, just to make sure I'm using the same battery. All right. So you want me to turn it on? Let's go. There. Look at this. Once you close the switch, once it is turned on, two light bulbs are glowing, of course. Will they glow if I connect them in parallel? Let's see that. Of course they do. What is the difference you understand here? What is the difference you can point out when the two bulbs are glowing? It's clear the intensity of these bulbs is lower compared to the intensity of this bulb, right? Did I do any trick? No, I didn't do any trick. See, this is 9 volts. This is also 9 volts. The energy driving the charge is the same. So what is happening here? In parallel circuits, energy is drawn from these two nodes straight from the battery. But in this case, it is getting distributed. Voltage in a series circuit gets split among the components. Rule number one. Voltage in the parallel circuit stays same. No, I want to check it. Yes, you can always check it. How can I check the voltage? How can I check the voltage? Easy. Go to a voltmeter there and try to check the voltage across. There you go. Okay, this is positive. That is negative. Okay. There we go. 4.5 volts. How many volts is the battery now? Battery is giving us 9 volts. All right, so let me turn on the values. There. Okay. So it's 9 volts and there's 4.5 here. And also, okay, let me put it like that. One more. Let me take that, a positive there, negative there. 4.5, 4.5. So what do we learn here? When components are connected or the load is connected in series, the voltage gets distributed among the components. In this case, two light bulbs, each light bulb having 4.5 volts. Now, what happens? What happens in parallel? Let's see. I want to use the same one. Go. So, oh, what did I do? Okay. Go there. Positive and negative there. See, this is 9 volts. This is 9 volts. Let's see. Let me see there. There. Why? Not showing anything. Why? If I didn't connect it properly. I didn't connect it properly. Now, there you go. In parallel circuit, the voltage is equally given to, of course, even here, distributed, but here it's not distributed. Total voltage is given to all the components which are connected in parallel. You can see that is the reason these are definitely glowing brighter with more intensity when compared to circuits, the series circuit, wherein light bulbs are connected. Series number one. So this is about voltage now. What about the current? I'm going through them. Will it change or will it stay the same? So this is voltage. What do we notice? In voltage, series circuit, the voltage gets distributed. Parallel circuit, the voltage is same, and they get the benefit of total voltage. Let's get on to current. Let's measure some current now. How do we measure current? Do you remember? How do we measure current? Always a voltmeter is connected in series in a circuit. So just select a point where you want to connect to now. Okay, let's see. Ammeter is here. All right. Just select a point where you want to connect an ammeter. So go there. I just want to connect ammeter there. So what I do, I connect that there. Oh, that's okay. That's really fine. We got 0.45 amperes. Okay. So how much current flows through each bulb? So in series, 0.45 amperes. Now I want to check the other end. For example, let's see right there. Will it vary? Is it any different? If I connect somewhere over there, let's see. What happens there? Let's see. Okay, what did I do? I just connected. Oh, this is also 4.5. Oh, all right. What if, what is the current flowing between these two light bulbs? Uh, let me see. Curious on what might be the current between these two light bulbs. Let me place a mirror here. It's also 4.5. So what did we learn here? In series circuit, throughout the circuit, current constant. It doesn't change. 0.45, 0.45, and 0.45. Right? Now you can ask me, is it the same in parallel circuit? The same. I don't know. I'm not sure. Let's see. Let me take an ammeter there. Yeah, it's here. Just like go. Oh, 0.9, 0.1, 1.8 amperes. What happened here? Why did this happen? It was same in a series circuit, in a parallel circuit. It's not. What can we do? I just want to check if this 1.8 amperes, the current flowing through the circuit, is same to this bulb or not. What can I do for that? Let me check that. Let me do this. That, like that. It is not. The total current driven, maybe by this charge driven, the flow of current is 1.8 amperes, wherein the current flowing through this light bulb is 0.9. You can guess what this is, right? It's not a difficult guess. Easy. Let me check that too. 0.9. Yeah, of course, the light bulb is the same. It not change any light bulb. See, the resistance of this light bulb is 10. Resistance of this light bulb is 10. So of course, now the current is distributed. Oh, this is like opposite to what happened in series circuit to voltage. What happened to voltage in series circuit? It got distributed to the components connected in series. 9 volts got distributed to 4.5, 4.5. This is opposite to that. In parallel circuit, the current 1.8 amperes is distributed to these two components connected in parallel, 0.9 amps and 0.9 amperes. Wow. So what did we learn today? What did we learn today? In series circuit, all the components, the current flowing through all the components which are connected in series is equal, same, the same, one and the same. And in parallel circuits, the current flowing gets distributed to all the components depending on the resistance. All right. So that is about series and parallel circuits. Now you can ask me, now let's see, let's explore this. You can ask me, if I increase the intensity, can I increase the intensity by increasing the voltage? Yes, of course you can. That doesn't mean now you can say, okay, this looks similar, but you cannot say that the intensity of the light bulbs connected in series and parallel are same just because you see them with equal brightness or equal intensity. 19 volts. You have doubled the input. So you have doubled the input source, which is voltage source in this case. All right. So both are not same. So let's get back to 9 volts. Yep. Intensity is less for sure, 100%. All right. So that's today's lesson. I hope you understand differences between series and parallel circuits, differences in intensities of the light bulbs connected in series and parallel circuits, also voltage and current variations in circuits connected in series and parallel. I hope you understood. See you again in the next video. Until then, see you. Bye-bye.